Hello and welcome to G Fun Facts Online. When we think of a wildfire, we picture towering flames, billowing smoke, and the brave firefighters on the front lines. It's a dramatic, immediate, and terrifying event. But what happens after the last ember is extinguished and the smoke finally clears? The danger, it turns out, is far from over. A new threat emerges, one that's silent, invisible, and moves with the first post-fire rainfall. Today, we're diving into the hidden aftermath of wildfires, exploring how they unleash a toxic legacy that poisons the very lifeblood of our ecosystems, our water. Imagine a healthy forest. It's not just a collection of trees, it's a giant, living sponge. The canopy of leaves and needles catches rain like an umbrella, slowing it down. The forest floor, a rich carpet of leaves, pine needles, and organic matter, soaks up that water, filtering it as it slowly seeps into the ground, replenishing aquifers. It's a perfect, natural water purification system. Now, picture that same forest after a high-intensity wildfire has torn through it. The trees are gone, the canopy is ash, and the spongy forest floor has been incinerated, leaving behind bare, scorched earth. But the fire does something else, something truly strange. The intense heat can bake the top layer of soil, creating a waxy, water-repellent layer. Geologists call this a hydrophobic layer. For our purposes, think of it like the ground has suddenly put on a waterproof raincoat. It can no longer absorb water. So when the rains do come, instead of a gentle soak, you get a flash flood. Water rushes across this sealed surface, unable to sink in, and it becomes a powerful transport system for everything the fire left behind. And what does it carry? A toxic slurry, a cocktail of contaminants that gets washed directly into our streams, rivers, and lakes. The most immediate and visible component of this slurry is sediment. We're talking about massive amounts of ash, soil, and debris. Studies have found that in the first year after a fire, the amount of sediment pouring into waterways can be anywhere from 19 to almost 300 times higher than pre-fire levels. 300 times! This turns clear streams into thick, muddy torrents. This isn't just an aesthetic problem. All that sediment clogs the gills of fish and smothers aquatic insects at the base of the food chain. For humans, it creates a nightmare for water treatment plants. Their filtration systems, designed for normal levels of cloudiness, get overwhelmed and clogged, requiring expensive and constant maintenance. The sediment can also fill up our reservoirs, reducing the amount of water we can store for the future. Carried along with that mud is a huge pulse of nutrients, specifically nitrogen and phosphorus. These are the key ingredients in fertilizer. In a healthy forest, they are locked up in the vegetation and released slowly. But a wildfire acts like a massive, instantaneous release, dumping a huge load of these nutrients into the water all at once. What happens when you over-fertilize your lawn? You get a huge flush of growth. The same thing happens in a river or a lake. This sudden nutrient overload triggers massive algal blooms. You've probably seen pictures of them. Thick, green scum covering the surface of the water. These blooms are not only ugly, they can be toxic, producing compounds harmful to wildlife, pets, and people. And when this massive amount of algae dies and decomposes, the process consumes all the available oxygen in the water. This creates what scientists call dead zones, areas where the oxygen levels are so low that fish, crabs, and other aquatic organisms literally suffocate and cannot survive. The story gets more sinister. Wildfires can also unlock and mobilize contaminants that were previously stable and locked away in soils and plants. I am talking about heavy metals. Many soils naturally contain metals like mercury, lead, and arsenic. A fire can change their chemical state, making them more mobile and easily washed away by rain into the water supply. This problem becomes even more acute in regions with a history of mining. Think of the American West, where for over a century, mining operations left behind waste rock and tailings piles rich in arsenic and other toxic metals. Over time, forests grew back over these areas, seemingly healing the land. But when a wildfire burns through this recovering landscape, it burns away the vegetation that was holding that contaminated soil in place. It's like ripping the bandage off an old, toxic wound. The first rains then flush these legacy pollutants, this toxic history, directly into the rivers that towns and cities downstream rely on for drinking water. And these metals don't just wash away. They can settle in the stream bed, persisting for years, a long-term source of contamination. Perhaps the most frightening part of this toxic cocktail comes from fires that burn at what is called the wildland-urban interface. This is where human development pushes up against natural, fire-prone areas. When a wildfire sweeps through a community, it doesn't just burn trees. It incinerates everything in its path: homes, cars, businesses, and all the synthetic materials inside them. The ash left behind from these fires is a complex chemical soup. It contains elevated levels of lead, chromium, copper, and other toxic metals from burned electronics, paint, and treated wood. But the real alarm bell for scientists and public health officials is what happens to our water infrastructure itself. The intense heat of a modern wildfire can be hot enough to cause the thermal degradation of plastic water pipes, specifically PVC and HDPE pipes that are common in water distribution systems. When these plastics break down under extreme heat, they can leach a whole host of dangerous chemicals into the water system. The most concerning of these is benzene. Benzene is a volatile organic compound, or VOC, and it is a known human carcinogen, meaning it causes cancer. After the devastating 2018 Camp Fire destroyed the town of Paradise, California, officials tested the water. They found benzene levels that were staggeringly high, far exceeding the safety standards set by the EPA. Residents were told not to drink, cook with, or even bathe in the water for months. And benzene isn't alone. Other toxic VOCs found in post-wildfire water systems include toluene, xylene, and styrene, a chemical menagerie released from our own melted infrastructure. This contamination isn't a problem that just goes away after the first few rainstorms. It has a long, stubborn shadow. A comprehensive study that looked at over 500 watersheds in the western United States found that the impacts are surprisingly persistent. Elevated levels of nitrogen, phosphorus, sediment, and dissolved organic carbon can remain in rivers for up to 8 years after a fire. 8 years! This long-term pollution fundamentally changes the chemistry of the water. The influx of burned organic material changes how the ecosystem stores and processes carbon. The very makeup of life in the water changes. For instance, scientists have observed that ponds and wetlands that get inundated with post-fire runoff can become ideal breeding grounds for insects like mosquitoes, while the populations of the good guys, the essential microorganisms and zooplankton that form the base of the aquatic food web, plummet. The entire ecosystem gets knocked out of balance, and it struggles to recover for a very, very long time. So, what does this all mean for us? The risks to human health are significant. Drinking, cooking with, or even bathing in water contaminated with this post-fire cocktail can lead to a host of problems. In the short term, people can experience nausea, vomiting, diarrhea, and skin rashes. The long-term risks are even more serious, including an increased risk of cancer, kidney problems, and reproductive issues from exposure to carcinogens like benzene and heavy metals. For the people who run our water treatment facilities, a wildfire upstream is a multi-headed monster. First, they have to deal with the sludge, the massive increase in sediment that clogs their filters. Then, they have to handle the surge in organic matter. When they add chlorine to the water for disinfection, as is standard practice, that chlorine can react with all the extra organic material from the fire to form harmful chemicals called disinfection byproducts, some of which are also carcinogenic. And finally, they have to figure out how to remove chemical contaminants, like benzene. This often requires highly specialized and very expensive treatment methods, like activated carbon filters, that many smaller or rural water districts simply can't afford. In some extreme cases, like in Paradise, the contamination can be so severe and widespread that conventional treatment is not enough, forcing communities to undertake the massive, multi-year task of completely replacing their water distribution system. The picture we've painted today is a sobering one. The smoke from a wildfire might clear in days, but its toxic signature can haunt our waterways for nearly a decade. As climate change continues to drive hotter, drier conditions, leading to more frequent and more intense wildfires, this threat to our water is only going to grow. It is no longer just a problem for remote forest areas. It's a direct threat to the safety of our drinking water. So what can be done? The solution has to be as complex as the problem. It involves better forest management practices, like prescribed burns and thinning, to reduce the risk of catastrophic fires in the first place. It means designing more resilient water infrastructure that can withstand these events. And it requires investing in advanced water quality monitoring and treatment technologies to tackle the unique chemical cocktail that follows a fire. The health of our rivers, our ecosystems, and ultimately ourselves depends on us looking beyond the flames and addressing the silent, toxic flood that follows. Thanks for tuning in to G Fun Facts Online.